Hi everyone, so here are our review questions, and our final exam will base on the topics that were covered after midterm exam. So up to midterm exam we had binomial distribution, and after midterm exam then we started with the distribution of the continuous variables, or probability distribution of the continuous variables, where we discussed about the normal distribution. We also discussed about confidence interval, hypothesis test, correlation, and regression. So our final exam will come from those topics. And here we have a number of questions which are more or less the same as our final exam. So if you can review this and get confident with these questions, so you should not worry about our exam. So the first question here says, suppose a normal random variable with a mean of 12 and standard deviation which is 6. So what is the z-score of x equals to 2? So to answer this question, we need to know the formula for z-score, and we know that z-score formula is xi minus average divided by standard deviation. And so once you know the formula, then it's easier for you to do the calculations. It's good to organize your data so that you can use Excel function easily. So let's write here mean or average. So we have average of 12, standard deviation, and then x value is 2. So to find z score, so just put equal sign and then skip one cell, and so put equal sign, and so we will take x minus average or x minus mean. So it is 12 minus mean, which is 12, and then close the bracket, and then divided by the standard deviation. Just click on the standard deviation and enter. So we know that the z-score of x when x is 2 is minus 1.67. So we can say x value, which is 2, is minus 1.67 standard deviation from the center, from the mean, and the mean is 0. Remember, when we standardize our values, average becomes 0 and the standard deviation is 1. So in this case we have found the z-score just by using the formula, and you can see how when you organize your data it becomes easier for you to do the calculation. So you can interpret this and say that x equals to 2. When x is 2, it is minus 1.67 standard deviation from the mean. So that's one question. So let's go to the second one. It says, suppose a normal distribution has average or mean which is 20 and standard deviation is 6, and therefore we need to find the z-score for x when x is 18. So we're going to do exactly the same, and all I can do here, I'll copy everything because the questions are the same, and so I'll paste here, and all I have to do is to change these values. Remember, we're working on this particular question. So average in this case is 20, not 12, and then standard deviation is 6, and x is 18. So I don't have to do the z-score again because I copied everything, and so I have my z-score, which is minus 0.33, and so it means that 18, which is the value of x, so you can say 18 is minus 0.33 standard deviation from the mean. Let's look at this question here. It says, what is the z-score of x equals to 1 for a normal distribution with mean of 12 and standard deviation of 2? So I'm going to leave you to complete that question. So just for exercise. Now let's work on this question, which says, suppose a normal distribution has a mean which is 20 and standard deviation which is 4. So it says, between what values of x does 68 of the data lie? So here let me put x, assume that this variable is x. So between what values of x does 68 of the data lie? And between what values of x does 95% of the data lie? And finally, between what values of x does 99.7% of the data lie? So you can see that this question is based off the 68, 95, and 99.7 rule, which is the empirical rule of standard deviation. Now, the good thing is we are given average and the standard deviation. So we can find the boundaries or the intervals that will give us 68% of the data, and 95, and so 99. So in this case, I'm going to write here about 68%. And so we have average or mean, and then standard deviation. And then we have x, which will not even x. So with 68, we have constant. And it will be 1, because we're going to say 68% of our data will lie between 1 standard deviation to the right and 1 standard deviation to the left. And so average here is 20 and standard deviation is 4. Once we have this information, then we can find lower bound or lower limit, and also we can find the upper limit. To get the lower bound, you can remember the formula, which says that it is average minus 1 standard deviation, and the upper bound will be average plus 1 standard deviation. So in this case, I'm going to put equal sign to find the lower limit, and I will click on 20 minus 4 times 1, or 1 times 4. And in this case, we're going to get the lower limit. To find the upper limit, so I'm going to put equal sign, click on 20 plus 1 times 4. So for the upper limit, we're going to plus, and we have 24. So to respond to the first question, we can say that between 16 and 24 values of x, we can find 68% of the data, or about 68% of the data will lie between 16 and 24. So let me write here about 68% of the data will lie between the lower bound, which is 16, and 24. So now I want you to do, or probably let's work together for 95%. So about 95%. So in this case, or according to the empirical rules of this empirical rule of standard deviation, about 95% of the data will lie between 2 standard deviation to the right and to the left. So I can copy everything. Let's copy and paste it here. So in this case, you can see that we also copied the functions. And all we need to do here is to change the constant. So 95% will lie between 2 standard deviations. So our constant will be 2. And if you can enter, you can see that the lower limit will be 12 and the upper limit will be 28. So we can conclude by saying that the 95% of the data will lie between 12 and 28 in the distribution. So I want you to complete this about 99.7% of the data. In this one, the constant will be 3, because it says about 99.7% of the data will lie between 3 standard deviation to the right and to the left. And so all you're going to change is just the constant. Please find answer to that question. And so in exam, we may have this kind of a question and it shouldn't take you long to complete it. So the next question is about, it says, suppose X is a normal random variable with average, which is 5, and standard deviation, which is 6. And Y is another normal random variable with average, which is 4, and standard deviation is 3. So suppose X equals to 17 and Y equals to 17. So compare their performance. So we can bring all of them into one scale, and we can do so by finding the Z value. So remember, our formula for the Z value is known. It is the one that we had on it. We had it here. So I'll copy everything from what we've done above, and then I'm going to paste it here, but we'll use the same, we'll just use the formula for our calculation. So let's try to work on X value, and then we'll work on Y values. We're going to work on X, and then we'll work on Y. So the Z score for X, when X is 17, and we have to look for the average. So average is 5, and standard deviation is actually 6, and X is 17. So I'm going to put 17 there and enter. So you can see that the Z score for this is 2. Now I'm going to select the outcome, copy, and I'm going to paste. And so now we're going to look at Y, the Z score for Y. So we have Y, and then x here will be y. So y is 17, same as x. And so let's look at the average. So y is a normal random variable with average of 4 and standard deviation is 3. So we have 3 and then we have 4 and enter. So you can see the z-score for y is 4.33, and that is different from the z-score for x, which is 2. And in this case we can say that y is better than x because it is 4 standard deviation away from 0, while x is 2 standard deviation away from 0. So y is better than, the performance of y is more than that of x. So expect to get one question in exam that looks exactly like that one. So now the other question says, the final exam scores in statistics class are normally distributed with a mean of 33 and a standard deviation of 5. So you are supposed to find probability that a randomly selected student scored more than 35 on the exam, and then finally the probability that a randomly selected student scored less than 35, and then we have 90% of the students scored less than what value, and finally 40% of the students scored more than what value. So we have here we have these probabilities. So it means that probabilities are given 90 and 40, or 90% and 40%. So in this case, we're going to look for a value, and on the top we are supposed to find the probabilities of the values. We're going to look at two functions. One is how we can, it is the function that can help us to find the probability, and the other one is to find a value. So in this case, we're going to use norm.dist, and the other one is norm. So the next thing we can do is to organize our data, and therefore we have mean, and the mean here is 33, and standard deviation is 5, and then we need to define probability. So we can define this probability. It says find the probability that a randomly selected student scored more than 35 on the exam. So it is the probability of x such that x is greater, because it says more than, is greater than 35. So that's how we can define the first part of this question. Here you can see that when we use norm.dist, the condition is we cannot find a probability of values greater than x. So we always look at the values less than x, or I'll say values to the left of the distribution. So in this case, we're going to have 1 minus probability of x such that x is less than 35, and therefore in this case just put equal sign, and now we can apply our function. which is normDist, and select the function. Sorry. So when if you're using normDist, we are required to put values of x, and then mean, standard deviation, and cumulative. And remember that our cumulative will always be true. So in this case, our x is 35. So I'm going to put 35, comma, and then click on average, comma, standard deviation, comma, and then I'll select true and close the bracket. And if you can enter, you can see that so we need to put 1 minus and enter. So the probability that a randomly selected student scored more than 35 on the exam is 0.34 or 34458. So that's all for the first question. Now let's look at the second question, which says find the probability that a randomly selected student scored less than 35. So for this question, let me just go here and define. Let's define the probability, and we're going to use mean and standard deviation, which are provided. And in this case, we are looking at the score that is less than 35. So probability of the score that is less than 35. And so we're going to have probability of x such that x is less than 35. And in this case, we can apply the function directly. We don't have to take 1 minus because it's to the left side, and therefore just put equal sign and type the function, which is normDist. Select that function, and then we're going to put values of x. Here we have 35, and then average is 33. Average is 33, and then standard deviation, sorry, we don't have to type average. You can click here, comma, click on 5, and then true, because it is cumulative, and it is 0.66. So we're looking at the value, the probability of the values below 35, and the probability of the values above or more than 35. That is the second question. So the third question asks 90% of the students scored less than what value. So now we are looking for a value given probability, and therefore we're going to use this function. And so we'll start. So we're looking at 90%, or the scores less than 90%. So in this case, just put equal sign and type norm inverse instead of normDist, and you're supposed to put probability, and it should be 90%, and then we have to put average, standard deviation, just close the bracket, and in this case, if you're going to enter, you'll see that we have 39. And this one, let me say 90%. So the value equals to 39. Let me copy this and paste it here. points to 2 decimal. Let me reduce that to 2 decimal points. So that's the value. And now we are asked 40% of the students scored more than what value. In this case, we are looking to the right, and therefore, let me write here 40%. And in fact, we're looking at more than, greater than 40%. And this one, it is less than 90%. So when we are looking at greater than 40%, it means we are looking to the right. And so let's look at the other side, to the left. So we can say, we can take 1 minus, so put equal sign 1 minus 40%. So values to the left side will give us 60%. And so in this case, now we can apply the function, which is norm inverse. And then we're going to click on 60 because that's the probability. And then average is 33, standard deviation is 5. And then we can close the bracket and enter. So the value will be 34.27. So that's how we can find probabilities and also a value when either is given. If we have a value, we can find probability, and if we have probability, we can find a particular value. So now let's look at this example, which says the basketball scores for a school team are normally distributed with a mean of 86 and standard deviation of 3. Find the probability that a golfer scored between the 83 and 89. So in this case, we are given mean, and our mean is 86. Standard deviation is 3. And then we need to define probability. So let's go probability. Let's define probability. And you can see we have in between probability. So we can say probability that 83 is less than x, and x is less than 89. So to find the probability of in between, first of all, we need to define probability of x such that x is greater than 83. So x is greater than 83. That's the first one. And in the second one, we have probability of x such that x is less than 89. So this one is not possible to use Excel function to find it. So we can rewrite it as 1 minus probability of x such that x is less than 83. But this one will be okay. So in this case, we can rewrite the whole equation, or actually we can apply the Excel function, which is norm test, and we'll use the in-between, we'll do the in-between calculations. So put equal sign, type norm dist. So I'm using norm dist. You can put dot, that will be the same. Or let me just do exactly what you've been doing. So I'm going to use norm.dist as usual. And so if you can see, we need x. Now we're gonna take the large one minus the small one. So we're gonna take probably x value will be 89, and then average will be 86. Standard deviation will be 3, and this will be cumulative. Close the bracket and then minus norm. So we want to minus this one here. You can see it's 1 minus, so we're going to minus it. And then our x will be 83, and average will be 86. Standard deviation will be 3. And then that will be cumulative, and then close the bracket. So I hope you can remember how you can find the in-between probability. So that is 0.68269. So let's look at this question. It says a citrus farmer who grows mandarin orange finds that the diameters of the oranges harvested on his farm follow a normal distribution with a mean diameter of 5.85 and a standard deviation of 0.24. So we're supposed to find the probability that a randomly selected orange from this farm has a diameter larger than 6, and then we work on the 90% and 35% as we worked on the question above. So you can repeat exactly the same as what we did. So we have mean, and that mean is 5.85. Standard deviation, which is 0.24, and then we have x, and we put xi. In this case, it's actually 6. This one here, and then let's work on the percentages. Percentages. So we have 90%, and then we have 60%. So now we need to use the two so we need to use the two functions, norm test and norm inverse. So in this case, I'll just put equal sign and type norm dist or norm.dist, and x is 6, comma, average, comma, and standard deviation, comma, and then find cumulative. And so that's the value we can get. And for the 90, so here it says less than 90%. and then we have greater than 35%. So we need to find values. And so in this case, we're going to use norm dot inverse, where we're going to put the 90% and then average and standard deviation. Close the bracket and enter. And so these are the values. And greater than 35, all we need to do is just take minus 1, 1 minus 35%, because we are talking about greater than what value. So we will look at the opposite of this to the left side, and so that will be 65. And so to get the value, just put equal sign and the function, which is norms inverse, and then click on that probability, average and standard deviation, and close the bracket and enter. So we have a value. So that's all with the normal distribution.